Okay, let's go through the Kahoot quiz, the answers for the Kahoot quiz last week. Now, first question, what are the color bands on resistors? They are not for decorations, right? Not for decoration. Um, they are actually there to show the value, value of the resistance. Um, each color will represent, right, is there to represent a number, right? As to how next time we will teach you, right? Resistors look like that, right? Each color band down there represent a number. Now, don't have to know it now. Just know that the color bands are there, right, to represent the resistance of the resistor, right? To tell you what is the resistance value. Now, question number two, right? Which one is the correct symbol? Now you're given a few. Which one is the correct symbol? The first one, right? Resistor, very easy. It's the first one, resistor, right? Resistor, a rectangle with two terminals, resistor. This thing like that, right? Is also a resistor with one line down here, an arrow down here. This is a potentiometer. Potentiometer, alright? Then this is the correct one, variable resistor. Now, both these and these have potentiometer have a knob for you to turn. Same thing for variable resistor, right? The only difference is one is two terminal, the other one is three terminals, right? Resistance, right? Question number three. Resistance between two of the terminals of potentiometer is fixed, right? Which are the terminals? Okay. They show you this picture down here, right? They tell you there are two terminals where if you measure the resistance value will always be the same, no matter how you turn the knob, right? The third one, this one represent the knob that you can turn. Alright, so which two terminals will always remain the same? The resistance of value will remain the same. Of course, it's A and B. A and B. Alright, because if you leave this thing open, you do not connect this to anywhere. Alright, you connect A and B to a battery, for example, right? Let's say I connect A and B. Right, A and B, can see or not? I connect it to a battery. Alright, I connect it to a battery. The current will flow from here, flow here, then flow across the resistance. Now, don't care whether I turn this thing, I turn, move until here or move until here, doesn't matter, alright, because the current have to flow from A all the way to B, because this is open, alright. But however, if I do my connection like that, if I do my connection, okay, let me show you. If I do my connection in this manner, okay, this is A, this is B, this is C. If I connect a battery, the positive side goes to C, the negative side go to A. Now what happens is when I change my value, right, I turn the knob, right, current will flow this way. So if you shift this point all the way until here, right, current will have to flow through very little resistance, right, and then you return. So of course our current will be higher. If I turn this thing all the way over here, right, all the way over here, this is A, right? Okay, current will have to flow here, right, flow here. Now travel a lot of resistance before coming back here, right? So the resistance is higher, right? Resistance higher, current lower, right? Number four. Right now, this one, what's the answer? Question: the resistance between two terminals. Of course, the two terminals that are fixed is A and B. Right. Number four. Let's go on to number four. Lights in the drawer. Now, this light in the drawer. Now, you are designing something like that. All right. You open the drawer, you see lights. You close the drawer. All right. The light will switch off. So they're asking you, which type of switch is the best? right, is most suitable. Micro switch, of course, is the most suitable, right? Slide switch, toggle switch, and tilt switch. I'll go and refer to your PowerPoint. All right, look at how all these switches look like. Micro switch is the one that you will fix, right? You will fix down here, right? When you close, it will cut off, right? Cut off the current, break the circuit. So micro switch is the most suitable. All right. Okay. Which connection protect LED from damage? Which one will protect LED from damage? Now, the first one. Take a look at the. Okay. The first one. Current will flow this way, flow until here. I already tell you, LED only allow current to flow in one direction, not the other direction. The polarity is actually wrong. Alright, see current will flow positive side, right? Come here and then you will be blocked by the LED. So LED cannot, the current cannot flow anymore. So this is wrong. Now this one is the correct one, right? Flow until here, still can continue to flow, right? Can continue to flow. So you have one resistor down here protecting the LED from damage, right? Overcurrent damage. Right, how about this one? This one, the LED is not being protected by this resistor at all. Why is it so? Now, the LED still, the whole entire 5 volts is still being connected across the LED. Alright, the current will just flow like that without flowing through any resistor like this one. Alright, of course, current will still flow through the resistor, will still flow through the resistor, but the current and takes another branch. The current flow here will branch out, right? Some will come to the resistor, some will flow directly through the LED without being blocked by any resistor. Alright, so this one is again, it doesn't protect the LED. Want to protect LED, you must connect it in series. You put it before or you put it after, doesn't matter. But then it must be in series with the LED. Now number 6, potentiometer can be used as a voltage divider. What is the minimum voltage of VCB? Let's see. Okay, when they ask you VCB, that means they are measuring the voltage from this point to the center leg, alright, to the center terminal of the potentiometer. This is the potentiometer. Alright, you measure the voltage from here to here, right? So if you, because potentiometer you can adjust you can adjust the center terminal, center leg, you can move it all the way here or you move it all the way here. So they ask you what is the minimum. As we know, all right, the minimum voltage will go to the minimum resistance, right? So if you move this point all the way here, it is as good as, okay, let me draw this thing. Okay, can you imagine a resistor like that? This is A, this is B. At the same time, C is also here. If you move this point all the way until the end here, right? What actually happens is like that. A is here, B is here, and then the point C is actually down here. It has got no resistance between B and C, right? No resistance between B and C. So if you connect a 5 volts down here, all right, between B and C will be 0 volt because there's 0 resistance. All right, there is 0 resistance. Let's go to the next one. How they now ask you what is the maximum voltage. Now what will be the maximum voltage then? Okay, the maximum voltage, if you want this one to take on the maximum voltage, of course you will have to set the resistance between B and C to the maximum, right? Set it to the maximum. Right, if you set B and C to the maximum, it will be as good as this. This is A, right? And this is B. Now, if you set C to the maximum, right, is as good as you set it this point. That means in between A and C there is 0 resistance. zero the resistance, and B and C the full resistance. So all the 5 volts will appear right across here. VCB will be maximum. So maximum is of course take everything, right? Take everything, all right? 5 volts. All right. Okay. Carry on with your lesson. Carry on with lesson. We will learn something new today, right? See you again.